So if you cast your mind back to the 2025 Lunar New Year Gala, you might remember this really pretty surreal sight.
Oh, yeah, the Unitree robots.
Right. China's Unitree H1 humanoids. They were up on the stage dressed in these vibrant traditional outfits, and they were perfectly flipping and manipulating handkerchiefs right alongside human dancers.
It was definitely a spectacle.
It was a highly choreographed, spectacular tech demo, but, welcome to June 2026.
Things have changed a bit.
Just a bit. The reality of humanoid robots right now is, well, it's a lot less about dancing on stage and a whole lot more about doing the heavy lifting in the darkest corners of logistics warehouses.
Exactly. They're off the stage now.
Yeah, and actively sparking these massive multi-billion-dollar boardroom deals. So today, for this deep dive, we're mapping out the real, frankly, unglamorous humanoid robotics boom.
Which is where the actual fascinating stuff is happening.
Totally. We're stepping completely away from the flashy viral videos. We want to uncover the invisible picks and shovels companies that are actually building the internal guts of these machines and, look at the hidden geopolitical choke points threatening to bring this entire global industry to a grinding halt.
Because it really is staggering how fast this technology is leaping from the lab into the real world that you and I live in.
It really is.
And the pace is just relentless.
Yeah.
To truly grasp what you are watching unfold across these industries right now, I mean, we really need to frame this as a raw industrial revolution.
Okay, I like that framing.
Yeah, because the most compelling story unfolding right now isn't actually the shiny metal robots themselves, as mesmerizing as their movement has become.
Right, the dancing is cool, but it's just the surface.
Exactly. The narrative driving the billions of dollars in investment is the global supply chain. It's an entire industry desperately trying to figure out how to build these machines at a scale of millions.
And presumably how to make them affordable enough for a business to actually buy.
That is the million, or I guess billion-dollar question.
Let's follow the money then. Because to understand how a business actually buys a humanoid in 2026, we have to look at how these robotics companies are proving they can generate real revenue. Which brings us right to Agility Robotics.
A huge player right now.
Absolutely. They are making a massive move to go public via a $2.5 billion SPAC deal. They're merging with Churchill Capital Core ECI under the new ticker AGLT.
Right.
And for anyone who isn't constantly watching the markets, a SPAC is essentially a special purpose acquisition company. It's a blank check shell company that is already publicly traded. So Agility merges into it as a shortcut to get onto the stock market without the agonizing roadshow of a traditional IPO.
Yeah, and the financial architecture of this Agility deal is really telling.
How so?
Well, they are pulling in over $620 million in gross proceeds.
Right.
And a crucial piece of that is a $200 million PIPE.
A private investment in public equity.
Exactly. And Foxconn is leading that specific investment.
Oh, Foxconn.
Right. When the largest contract electronics manufacturer in the world puts their money down, they aren't investing in a science project.
No, they're looking for scale.
Exactly. They are investing in mass manufacturing potential. And if you look at the stark contrast with Agility's competitors...
Like Figure AI.
Yeah. Figure AI is staying private, raising cash at these astronomical tens of billions valuations.
Right.
And Unitree over in China is reportedly eyeing a traditional IPO worth like $7 billion. But Agility is taking a much more grounded route to Wall Street.
It seems like their entire corporate ethos right now is deployment over demos.
Which is incredibly pragmatic.
Yeah, their bipedal robot, Digit V5, it isn't just doing backflips in a lab, it is out there sweating figuratively for paying customers.
It's actually working.
Yeah, they've already moved over 100,000 inventory totes for GXO Logistics, and they have booked more than $300 million in multi-year orders. But here is the mechanism that I find absolutely fascinating. They aren't actually selling these robots.
No, they aren't.
Instead, they operate on a robots as a service model, or RIAS.
We're RIAS model.
Yeah, so it's like subscribing to Netflix instead of buying hundreds of individual DVDs. A logistics company just pays a monthly subscription fee for the robot's labor.
Which makes a lot of sense.
Right. I look at this and wonder, is this subscription model literally the only way to sneak these wildly expensive machines onto a warehouse floor? I mean, if you ask a warehouse manager to drop $100,000 up front per robot, they'll just laugh you out of the building.
They absolutely would. Turning that massive capital expenditure into a predictable operating expense is really the only way the math works for logistics companies right now.
Because the margins are so tight.
Exactly. Think about warehouse work, taking heavy totes off a conveyor belt, walking them to a staging area, putting them on a shelf. It's dull, physically destroying work.
It really is.
And these facilities are chronically understaffed. But the upfront cost to replace an entire shift of human workers with a fleet of humanoids, that is enough to bankrupt a regional logistics hub.
So renting them is the workaround.
Yeah, by renting Digit on a subscription basis, Agility removes that financial terror for the customer. And from Wall Street's perspective, this RIAS model is the holy grail.
Because it's recurring revenue.
Exactly. It creates a recurring, sticky, predictable revenue stream. Investors will eagerly justify a $2.5 billion valuation when they can clearly forecast monthly subscription revenue compared to relying on one-off hardware sales in an industry that is honestly still finding its footing.
That makes perfect sense. But if a company is renting out fleets of million-dollar machines, those robots cannot be breaking down every Tuesday.
No, they have to be bulletproof.
Right, so the durability comes down to the internal hardware. And this is where we step away from the glossy robot brands and look at the invisible companies making the parts.
The picks and shovels.
Exactly. A $2.5 billion robot company doesn't smelt its own steel or build its own sensors from scratch. The real gold rush opportunity lies in the hidden suppliers.
Yeah, and this is where it gets really interesting.
So we were looking at some financial analyses for this deep dive, and Citron Research specifically points to a company called Vishay Precision Group, or VPG.
VPG is a fascinating case. They operate almost entirely behind the scenes.
Right.
They are a niche provider that was actually spun off from Vishay Intertechnology, and they specialize in hyper-precision measurement and sensing technologies.
Okay.
Citron's analysis positions them as the quiet, unrecognized backbone for Tesla's Optimus robot.
The technical imagery in their analysis is just brilliant. They talk about the tactile sensors needing to be so profoundly sensitive that a cold, metal robotic hand can delicately hold a raw egg, apply just enough pressure to crack the shell, and pull it apart without instantly turning it into a scrambled mess on the counter.
Which is an insanely difficult engineering problem.
Right, like I have trouble cracking an egg sometimes.
We all do. Achieving that level of microdexterity requires an array of advanced tactile force and torque sensors that constantly feed physical feedback to the robot's brain.
And Citron links VPG to Tesla, right?
Yeah, they pieced together a highly compelling timeline here. In late 2023, VPG quietly announced a major design win with a leading unnamed humanoid robot maker in a beta phase.
Unnamed, of course.
Of course. But barely a month later, Tesla held a massive event unveiling Optimus Gen 2, and the entire presentation revolved around those exact types of advanced tactile and force sensors in the hands and feet.
The timing is suspicious.
Very. And then fast forward to VPG's August 2024 earnings call, and their management team casually mentioned their customer plan to have thousands of robots running internally by the end of 2025.
Which matches Tesla's publicly stated internal deployment timeline to the day.
Exactly to the day.
Okay, I'd have to pause and challenge the financial logic here, though. For anyone who isn't glued to financial terminals, a PE ratio, or price-to-earnings ratio, tells you how much investors are willing to pay for $1 of a company's earnings.
Right.
In the AI boom, companies like NVIDIA regularly trade at 70 or 80 times their earnings. But VPG sits at a modest $300 million market cap with a PE ratio of just 24x.
It's remarkably low.
That is dirt cheap. If VPG is genuinely the secret hardware allowing Tesla's Optimus to crack an egg, how has Wall Street, an entity that will throw billions at anything vaguely related to AI, completely overlooked them?
Well, Wall Street suffers from a chronic lack of attention span.
Fair point.
The broader market chases the shiny, consumer-facing brands, NVIDIA, Tesla, OpenAI. VPG is bound by ironclad non-disclosure agreements.
So they literally can't tell anyone.
Exactly. They can't issue a press release screaming, hey, we supply Tesla. They are forced to operate in complete obscurity, buried deep in the industrial supply chain.
Wow.
And this is the classic picks and shovels dynamic. During a gold rush, the people mining the gold take all the risk and get all the headlines, but the people selling the picks and shovels quietly make the guaranteed profit.
They just sell the tools and walk away.
Right. The true unpriced value right now sits in these legacy engineering firms supplying the highly complex, totally unglamorous internal components.
And it isn't just the sensors, is it? The analysis also highlights Schaeffler, which is this massive legacy automotive supplier.
Yeah, Schaeffler is huge.
And they recently partnered with a UK-based company named Humanoid to supply something called strainwave gear actuators.
Strainwave gears are the unsung heroes of bipedal robotics. They really are. They're primarily deployed in the upper body, the shoulders and the arms.
Okay.
And their primary mechanical advantage is that they offer zero backlash.
Oh, let me break down backlash for a second because I think it's a great concept for you to understand if you're trying to grasp the mechanics here.
Yeah, go for it.
So if you tell a standard robotic arm to stop exactly 1 millimeter away from a fragile object, backlash is that tiny inherent looseness in the physical gears.
Like a little shutter.
Exactly, it's that tiny mechanical shudder that happens when the gears stop moving. In a heavy industrial arm assembling a car, that shudder doesn't matter. But in a humanoid trying to thread a needle, that shudder ruins the entire task.
It would tear the fabric.
Right. So strain wave gears eliminate that loose wiggle room entirely.
Furthermore, these specific gears from Schaeffler feature a large hollow shaft.
Which sounds like a mundane engineering footnote.
It does, but think about the sheer volume of data cables and power wires running through a robot's arm.
Oh, right. Like a nervous system.
Exactly. If those wires are strapped to the outside of the joint, they will snag on warehouse shelving or they'll pinch during a complex movement.
Which would be catastrophic.
A hollow shaft allows all the internal cabling to be routed straight through the center of the joint. It protects the nervous system of the robot and allows for a full 360-degree range of motion.
Okay, so Schaeffler designs the gears and VPG builds the sensors.
Yeah.
But who is actually manufacturing these components at a scale of millions?
That is the big question.
Because the manufacturing pipeline is experiencing a massive tectonic shift right now, straight out of the automotive industry, and it is heavily concentrating in Asia.
Yeah, the scale required to make a dent in the global labor shortage is monumental. Goldman Sachs released projections estimating that South Korean companies alone will command a 30% share of global humanoid robot production by 2035.
30% is wild.
It is. They map out a Korean supply chain capable of supporting around 74,000 units by 2030.
And the corporate maneuvering backing up those numbers is intense. Samsung just increased its ownership stake in Rainbow Robotics to 35%.
Right.
And they didn't just throw money at them. They pulled Dr. Jun Ho, who is a legendary founding member of Rainbow Robotics and a pioneer from KAIST, the Korea Advanced Institute of Science and Technology, and they put him in charge of a brand new future robotics office.
And that office reports directly to the highest levels of Samsung.
It shows how seriously they're taking it.
Absolutely. The broader Asian manufacturing base is completely retooling. Over in China, you have companies like Tuopu Group and Sanhua Intelligent Controls.
Automotive companies, right?
Exactly. They are taking their deep institutional knowledge from manufacturing car chassis and thermal management systems for Tesla's electric vehicles, and they are pivoting that infrastructure directly into building robot joints.
Wow.
Sanhua is actually the exclusive Tier 1 supplier for Tesla's linear actuator assemblies. Yeah, and they reportedly saw a 320% year-over-year growth in their robotics revenue in just the first half of 2025.
320%. It is the definition of a manufacturing evolutionary leap. It honestly reminds me of the theory of how dinosaurs evolved into birds.
Okay, I like this analogy.
Like you look at a traditional electric vehicle factory, and it is literally evolving into a robot factory. The underlying DNA, the electric motors, the battery management, the sensors, the actuators is remarkably identical.
The translation of skills is basically seamless. South Korea's competitive edge stems directly from decades of engineering perfection in automotive electric power steering and braking systems.
Well, because of the precision.
Right. A modern power steering system requires extreme precision, absolute reliability, and massive power density in a small space. Those exact same engineering principles are what you need to build the actuators that act as the muscles in a humanoid's legs.
That makes total sense.
However, you can assemble the most mechanically flawless robotic body in the world, and it is nothing more than an expensive paperweight without the data to drive it.
Okay, let's talk about that, because the data moat is arguably the most valuable asset in this entire space.
Artificial intelligence in robotics relies on vision language models, or VLMs. Think of it as giving eyes and hands to something like ChatGPT.
Right.
The AI needs to perceive a messy physical environment, understand what it is looking at, and then calculate how to physically interact with it.
Which is harder than it sounds.
Much harder. Goldman Sachs highlights that these massive AI models still struggle with tasks humans find trivial. An AI might know what a coffee pot is, but it struggles to find the handle in a cluttered sink, calculate the grip force, and understand the fluid dynamics of pouring the coffee without spilling it.
And the only way a machine learns how a coffee pot feels is by actually picking up thousands of coffee pots. It needs physical practice.
Physical deployment is the ultimate bottleneck for AI advancement. Currently, estimates suggest China has between 10,000 to 15,000 humanoids already deployed in real-world industrial settings.
That's a massive fleet.
Compare that to the US and Korea, which currently only have hundreds of units in the field.
Wow, just hundreds.
Yeah, and every time one of those 15,000 Chinese robots successfully picks up a weirdly shaped box or fails and drops it, that telemetry is uploaded. It creates a self-reinforcing flywheel. More physical deployment equals more diverse physical data collected.
And that rich data trains the central AI.
Exactly, which makes the next software updates smarter, making the robots more capable, which justifies even more deployment. The sheer volume of units sweeping across factory floors in Asia is compounding their data advantage by the hour.
Okay, so we have this brilliant, evolving supply chain leveraging decades of automotive expertise and a rapidly expanding data moat. But hidden inside all of this progress is a highly fragile vulnerability.
A huge vulnerability.
The entire industry is balanced on a geopolitical Achilles heel.
It is, and it comes down to the raw materials required for motion, specifically permanent magnets made of neodymium iron boron or NdFeB magnets.
Right, NdFeB. To understand why this matters, you have to look at the frameless torque motors inside every single joint of the robot. You cannot use standard iron magnets.
They just aren't strong enough.
Exactly. Without the extreme magnetic pull of neodymium, the robot cannot achieve the power density required to support its own body weight, let alone lift a 50-pound box.
And the volume required is staggering. A breakdown of the supply chain shows that every single Tesla Optimus requires roughly 3.5 kilograms of these specific NdFeB magnets.
3.5 kilograms per robot.
Yes, and the geopolitical reality surrounding those 3.5 kilograms is stark. China currently controls 85 to 90% of the global NdFeB production pipeline.
Wow, 90%.
Yeah, from the mining all the way to the incredibly toxic refining processes. And on April 4, 2025, China enacted sweeping export controls on rare earth minerals.
I remember that making headlines.
They now require a highly scrutinized export license to send these materials anywhere outside their borders. This single policy shift is the most severe threat to scaling Western humanoid production.
Let's put some hard numbers to that threat, because it's wild. If you look at Tesla's bill of materials, their stated goal is to crush the cost of an Optimus robot from an estimated $80,000 down to an affordable $20,000.
Which is an aggressive target.
Very. Now, the AI5 chip, the brain, accounts for about 26.5% of the current cost. Tesla is aggressively cutting that by moving production to Samsung, Texas, and spinning up their in-house Terafab semiconductor initiative to bypass reliance on Taiwan.
So they have a plan for the brain.
Exactly. And the mechanical actuators, which make up roughly 13 to 23% of the cost, will naturally get cheaper as they mass manufacture them, like car parts.
Yeah, economies of scale.
But those NdFeB magnets make up about 8% of the total cost. And that 8% is a hard floor.
You can't just code a software update to invent a new magnetic field.
Right. So we hear nonstop about the AI chip wars between global superpowers. Are you saying that the real bottleneck for the entire humanoid revolution isn't the silicon brains, but just 3.5 kilograms of magnetic rock?
That is exactly what I'm saying. The material science is absolute. You can achieve manufacturing nirvana, and you can spend billions building domestic chip fabrication plants like Terafab to secure the silicon logic.
Sure.
But no amount of Silicon Valley software engineering can bypass a raw materials embargo. If you are denied access to those specific rare earth magnets, the robot's physical muscles cannot move with the efficiency required for bipedal walking.
So it's a hard stop.
It is a hard physical limit. It demands either a massive diplomatic resolution or a painful, decade-long effort to spin up alternative rare earth refining capabilities in places like Australia or the US.
Which takes years.
Exactly. Until one of those happens, 3.5 kilograms of magnetic rock holds total leverage over the future of automation.
Man, when you step back and look at the vast ground we've covered today, it really changes how you see this entire industry.
It's a lot more than just viral video.
Oh, it is. We started with Agility Robotics ringing the opening bell, proving that a Netflix-style subscription model can turn warehouse drudgery into a $2.5 billion valuation.
Right.
Then we dug past the glossy robot brands to find the hidden gear and sensor makers like Schaeffler and VPG, who are quietly engineering the precision internals, while Wall Street is busy looking the other way.
The picks and shovels.
Exactly. We traced the massive manufacturing pipeline, watching the Asian auto industry literally evolve into a robotics powerhouse while simultaneously building an insurmountable AI data moat.
The flywheel effect.
Yep. And then we hit the hard wall of geopolitics, where the entire future of the humanoid workforce might hinge on an export license for 3.5 kilograms of magnetic rock. It is an unbelievably complex, fragile web.
It is, and the complexity of the supply chain is rivaled only by the societal shift it is about to unleash.
Yeah.
We've spent our time today analyzing the brutal industrial, financial, and geopolitical wars being fought just to build the physical bodies of these machines.
Just to get them built.
Right. But as you watch this unfold, consider the ultimate endgame. Once these manufacturing bottlenecks are inevitably solved, and millions of these robots hit the commercial market at $20,000 each.
Which they will.
What happens to the value of human labor when a machine can tirelessly move heavy inventory in a freezing warehouse all night and still possess the hyper-precise, sensor-driven touch required to crack an egg in your kitchen the next morning?
That is exactly the kind of question you have to start asking yourself as these machines move from the screen to the street. Thank you for joining us on this deep dive into the source material.
It's been great.
So the next time a video of a robot doing parkour goes viral on your feed, look past the acrobatics. Keep your eyes on the quiet supply chain moves, the raw materials, and the hidden data collection happening behind the scenes. That is where the actual future is being assembled.